Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Saroke Institute of Engineering and Technology, Kolhapur. The learning objectives for today's session are number 1, study of centrifugal pump. In this session, we are going to see the construction and working of an centrifugal pump, the difference between the centrifugal pump and reciprocating pump. And second, study of submersible and jet pump. The last types of the pump, submersible pump and jet pump, will be studied in today's session. This is the last session for the third chapter. Starting with centrifugal pump. The centrifugal pump works on a principle of centrifugal force. The centrifugal pump consists of number of different parts. The main four parts are: first one is impeller. The impeller is a rotating wheel on which series of backward curved vanes are fitted. The impeller is mounted on a shaft, and shaft is concentric with the casing. The shaft is coupled to the electric motor. Second, casing. Casing is the part in which all the assembly of an pump is fitted airtight so that no cavity, so that no leakage of water or fluid takes place. Third, suction piping system, and fourth, delivery piping system. The piping in for the pump at suction side and delivery east side. These are the different parts or main parts of the centrifugal pump that we are going to study in detail. With the first point, impeller. The impeller is the device consists of rotating wheel on which series of backward curved vanes are fitted. The impeller is mounted on a shaft, and shaft is concentric with the casing. The shaft is coupled with the electric motor. The impeller increases the velocity of water, which imparts kinetic energy, hence increases the centrifugal force on working flow, or so gives the pressure head. The vanes of impeller have different types and different application. The impeller is an important factor. This factor influences the operation of an centrifugal pump due to the pressure is created by an impeller. The impeller have different types with the which help to create the different and flow or the different pressure. The different types of impeller help in both the uh, in pressure development and in head. The types of impeller are shown in the figure below. The vanes of impeller having shrouds on both sides, as in case of radial inward flow reaction turbine. Such impeller is called as a closed impeller or shrouded impeller, as shown in figure A, and is used for pumping of liquids which are pure and free from foreign material. The impeller diameter here is relatively large. The vanes only have one base plate and no crown plate. These impeller are known as semi-open impeller or mixed flow impeller, as shown in figure B. These are used for pumping of liquid which are having some debris to some extent, that is impurities. To some extent, the flow leaves the impeller half axially and half radially for high volume and low pressure. The rotor is adjusted to maintain acceptable clearance. When the vanes ends are neither crown plate nor base plate, then the impeller is known as open impeller. These types of impeller are used for slurry, high velocity fluid. This is the simplest example of an impeller er, er, During the material selection for an impeller, the factors taken into consideration are mechanical force, liquid corrosion, erosion of solids, and the liquid and cavitation. The factors influence the operation of centrifugal pump due to an uneven pressure distribution on front and back of an impeller. An axial hydraulic force is always directed towards the suction side. The open impellers are typically small in diameter, inexpensive, and used in for pumps handling suspended solids like a mixture of water, sand and clay, etc. Semi-open impeller are used in medium diameter pumps and with liquid containing small amount of solid, a suspended solid called as derbies, or sewage water, or paper pulp, etc. And the closed or shrouded impeller are used in large pumps with high efficiency. These are also used for suspended solid in service without clogging, but will exhibit high wear rate. The closed impeller type is most widely used type of impeller for centrifugal pump handling the clear liquid. The next part of a centrifugal pump is casing. The casing not only contains fluid, but it is also the component in which velocity energy is transformed into pressure energy. The casing of a centrifugal pump is so designed that kinetic energy of water is converted into pressure energy before water leaves the casing. Considerable increases in the efficiency casing increases the efficiency of the pump. The principal casing shapes are of main three types, which are types of casing, which are as follows. The types are basically there are three types of casing as shown in figure: volute casing, vortex casing, and volute casing with guide blades. First, the volute casing. In volute casing, they are used almost in all types of pump. The spiral shape of volute wood casing with increasing sectional area has an uneven velocity oblique pressure distribution in its circumference as shown in figure. In smaller sectional areas, the velocity will be high with reducing velocity in large area pressure increases. This uneven pressure distribution results in radial force in the impeller plane, which results a shaft deflection constituting an oscillating load on rotating element. The magnitude and direction of thrust changes with the casing shape, mass flow rate, and affect shaft and bearing. In this casing, a considerable loss takes place due to formation of eddies. The second type is the vortex casing. It is improvised version of volute casing in which spiral casing is combined with a circular chamber as shown in figure B. In this casing, the eddies formation are reduced to a considerable extent and increase in the efficiency is obtained. And the third is volute casing with guide blade. In this casing, a ring of guide blades surrounding the impeller called as diffuser is implied and is very efficient as shown in figure. These guide blades are arranged at such an angle that water enters without shock and forms a passage of increasing area through which water passes and reaches the delivery pipe. Starting with third piping system of an centrifugal pump. Before understanding piping system, let us understand the different heads. First is a suction head. Suction head is defined as height of water column which will rise before arriving at the pump. Suction head is defined as height of water column which will rise before arriving at pump. And delivery head is defined as maximum height of water column which will reach by pipe after pump. For successful working of centrifugal pump depends upon proper selection of pipe size and piping layout. A centrifugal pipe has basically two types of pipe. A centrifugal pump has two types of pipes as shown in figure. The first one is suction pipe. This pipe plays important role for smooth working of pump. A poorly designed suction pipe causes insufficient positive suction head and vibration, noise, water hammering, excessive wear, etc. The laying of pipe should be airtight and a strainer footwall is connected at bottom of the suction pipe which restrict the entry of foreign material. Since the negative pressure at inlet of suction, its value is limited to avoid cavitation. The bend in suction pipe are provided and diameter is kept large to minimize the loss in suction pipe. For reducing axial thrust, suction pipe is also branched into two parts and liquid is allowed to enter the impeller from both sides. Such pump is called as double suction pump. And the second pipe is delivery pipe. A delivery pipe is provided with a check wall near the pump to protect the pump from water hammer and also regulate the discharge from pump. The size and length of the pipe depends upon the design requirement of the pump. Let us see the working of centrifugal pump. The centrifugal pump system as shown in figure below. The centrifugal pump is rotodynamic pump. The pump is driven by an external force or external power source, generally an electric motor, but other drives such as IC engine in steam turbine or water turbine can also be used. While selection of the drive, factors like power, speed and torque are taken into consideration. The centrifugal pump is used to raise a liquid from a lower to higher level by creating a required pressure with the help of centrifugal action. The centrifugal pump is the most common type of pump used in every household application or in every buildings. The first step in the operation of a centrifugal pump is priming. That is, the suction pipe and casing is completely filled with water so that no air pockets are left. Now start the pump by external power supply. The rotary motion of the pump impeller inside the casing full of water produces a vortex force which is responsible for imparting centrifugal head to water. The rotation of impeller causes reduction of pressure at the center. Hence, the water in suction pipe is to rush into the eye near to the rotating axis and is accelerated by impeller flowing radially outward or axially into diffuser or a chamber. The speed of the pump should be high to produce sufficient centrifugal head. This velocity head is converted into pressure head. The pressure increases with increase in radial distance due to centrifugal action to increase the flow rate of a fluid from where it exists into downstream piping system. Centrifugal pump are most common type of pump used to move liquid through a piping system and used for large discharge through smaller heads. Centrifugal pump are most often associated with radial flow type. However, the term centrifugal can be used to describe all impeller type rotodynamic pump including the radial, axial and mixed flow variations. Priming of centrifugal pump is the operation of filling the suction and pipe casing of the pump and a portion of delivery pipe completely with water before starting off pump to remove the air, gas or vapor from the parts of the pump. If the air remains inside the casing, discontinuity of fluid flow is caused. The difference between centrifugal and reciprocating pump as shown in figure. Centrifugal pump is simple in construction as less number of parts and reciprocating pump complicated in construction more number of parts. Centrifugal pump can handle dirty water, reciprocating pump cannot handle dirty water. Centrifugal pump requires less floor area, it is compact and simple foundation, whereas reciprocating pump requires more floor space area and heavy foundation. Centrifugal pump is suitable for large discharge and small head, whereas reciprocating pump is for less discharge and higher head. Due to rotating element, there is less wear and tear in centrifugal pump, whereas due to rotating reciprocating element in reciprocating pump, wear and tear is more. Proper balancing is in centrifugal pump, whereas balancing is not proper in reciprocating pump. Centrifugal pump require more starting torque. Reciprocating pump require less starting torque. Total weight of pump is less for a given discharge in centrifugal pump, whereas total weight of pump is more for a given discharge. Maintenance cost is also low for centrifugal pump as compared to the reciprocating pump, where maintenance cost is high. Suction and delivery valves are not necessary in centrifugal pump, whereas in reciprocating pump, suction and delivery valves are necessary. Centrifugal pump has less efficiency, whereas reciprocating pump has more efficiency. Thrust on crankshaft is uniform in centrifugal pump, whereas thrust on crankshaft is not uniform. Pumping liquid is done by a rotating element in centrifugal pump, whereas pumping liquid is done by reciprocating element in reciprocating pump. Centrifugal pump needs to priming, that is to remove air, whereas in reciprocating pump there is no need of priming. The next part is submersible pump. A submersible pump is a type of multi-stage centrifugal pump which has hermetically sealed motor coupled with an electric motor and enclosed in a single housing. It operates in a vertical position when whole assembly is submerged into the fluid to be pumped. The sealed electric motor spins a series of impellers as shown in figure below. The fluid in accelerated by impeller lose their kinetic energy in diffuser, where a conversion of kinetic to pressure energy takes place. Each impeller in series forces water through diffuser into the eye of one above it. Each impeller will build up pressure in stage. Other parts include radial bearing, bushing, distributed along the length of the shaft, providing radial support to pump shaft. The capacity of the pump is determined by the width of impeller well and its pressure by the number of impeller. Less number of stages pump may deliver a high volume of water at low pressure, while more number of stages a pump will deliver lower volume but at a greater pressure. Such as centrifugal pump as increase in well depth or discharge pressure will reduce the capacity. The submersible pump are single stage pump used in drainage, sewage pumping, etc. These are also used in general industrial pumping and slurry pumping. In also they are fitted with the borehole. Submersible pumps are used lower down a borehole and are most typically used for residential, commercial, municipal and industrial water extraction from water and oil wells. These are the application of submersible pump. Submersible pumps are efficient, high in capacity and require very less maintenance. The next point is jet pump. The jet pump as shown in figure consists of three sections: a centrifugal pump, a jet ejector, a nozzle or package, and a foot wall. The foot wall is a section connected to well or reservoir and maintains the pump prime, preventing the backflow. Jet pumps are centrifugal pump with an ejector nozzle, convergent divergent type of nozzle attached at discharge outlet. Its working principle is based on Venturi effect of Bernoulli's theorem. By utilizing construction to reduce pressure and provide suction. After priming the pump is fluid. After priming the pump, a fluid is pumped through centrifugal pump and enters an ejector nozzle. At the throat of converging section of ejector, the pressurized fluid is ejected with high velocity. Because of this, vacuum is created, developing low pressure at throat at section which draw or lift the required fluid from well or other source up to into the nozzle. This type is used in marine in to transfer the sea water. Uh, it is also used to move wastewater up to sewer line. Thank you. This is it for today's session. This completes our third chapter, chapter number 3, fluid machinery. Thank you. If you have any queries, you can directly contact me. Thank you.